Welcome back, ladies and gentlemen. Caymans, Mr. Eicher here, talking about some statistics in this lesson. We'll look at a stem plot, and we'll also look at some measures of center, like the mean and median, and we'll look at measures of spread, like the standard deviation. So a teacher asked his class of 26 students about the average number of hours they work at their job, and if the student is taking an AP class. Here are their responses. Students who are in an AP class, this student, for instance, works an average of 18 hours a week compared to this student, for instance. I guess they don't have a job. And then these are students who don't have AP classes. And we'll see if there's a relationship between work schedules, getting hourly pay at jobs, between students who have AP courses and those who don't. On this example, I have given you, excuse me, a back-to-back stem plot, a side-by-side stem plot. So I'd like to explain how to read something like this. But the question is, compare the center and the spread of number of hours worked for students who have an AP class versus those who don't. So let's check this out. First, we have this data on this side. Is all the data for students who have an AP course. Let me find a place to put this thing. There we go. So we have this 0 is going to represent numbers, single-digit numbers, whereas this 1 represents numbers that start with a 1. So this would be 10. This is another 10. That's a 1 and a 5, and then this 8 is a 1 and an 8. So we have 10, 10, 15, 8. Whereas in this first row up here, we'd have 0, 0, 0, 0, 0, 0, 0, 5, 0, 9, which obviously we don't really write the zeros. But in essence, that's what that 0 is doing. And then on the right side, this is back-to-back or side-by-side. On the right side, we use the same stems, 0, 1, 2, 3, and we have all these students who aren't taking any AP courses. So for instance, I just want you to think mentally really quick, what does this number represent? That would be 28. What does this number represent? That would be 12. What does that number represent? That would be 35. And on and on and on. This would be 30, that would be 25. All these are 0. But if you weren't actually told the data up at the top in this area right here, you would need to be able to interpret and read these numbers in a stem plot. Notice, we're going to erase some of this. Notice that in a stem plot, the numbers are put in order. So I'll just throw that out there. That these numbers, 2, 2, 5, 5, 5, 0, 5, 8, those are in numerical order. Just on the left side, they go in the other kind of order. You read them like that, 0, 0, 5, 8, and then 0, 0, 5, 9. But they are all organized. It makes it a little difficult if you had organized these as like something like that. You'd want to put them in order, which they are already in order here. Okay, so the question is, compare the centers. So when we compare the center, which one would you say has AP course or the non-AP course students? Which one of these sets of numbers would have a higher average or a higher center? So if we're just eyeballing it, it looks like the center here, like it's kind of right in between. Compared to here, the center might be a little bit lower, like in between here. Center, question mark, center. So it looks like the students who don't have AP courses, that they have a higher center, a higher average or median. We can calculate the median. The median is the middle number when they're in order, middle number when ordered. And these are ordered in a sense. So the middle number on the left, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle number would be the fifth number. So 1, 2, 3, 4, 5. So the median here, the median is 9. And the median over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 on this side. So the middle number would be the ninth number. One way to tell where the median is, if you take the number of data points, if you add 1 and divide by 2, that is the position, the location of the median. So on the left side, I counted 17 observations, 17 data points. If you add 1 and divide by 2, you're looking for the ninth data point. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median on this side would be 12. So it looks like the students who don't have AP courses typically work more hours. So we would say students, students who don't have AP courses typically work more hours at their job. Median is 12 versus 9 for AP students. Now we don't know why this is. So we're saying that no AP leads to more hours of paid work. But that association might go the other way, right? It might be because they want to work a lot of hours, so they don't have time for AP classes. Or maybe they decided to not sign up for AP classes because they wanted to get more hours. So whatever the direction is, we can say that the students who aren't in AP classes, they work more hours. We don't know why that is. Obviously, you need to ask them and see. But that would be comparing the center. Now, we could compare the mean. The mean just takes longer to calculate. So that's why I liked using the median instead of the mean. There's also a difference in variability or spread. So how spread out are the number of hours? This is also called the variability. So looking at these, let me get rid of some of these markings all the place here. Looking at these, we have which one's more spread out? So this one seems pretty compact, this side right here. It doesn't seem like there's a lot of variability. It seems like, like 18 hours, 18 hours or less. But there's a lot of students here who are working, that would be 10 or fewer hours a week. Compared to, notice the variability here. You have students who are working 0. There's not a lot of variability in that one STEM, but you could have students all the way over here working like 30-hour weeks. That's a lot of variability compared to this side. So one way to measure variability is the range. The range is a measure of variability or a measure of spread. So for the AP courses versus the not AP courses, for AP courses, the range is the max number minus the min number. So the range would be the max is 18, the minimum is 0. So 18 minus 0, the range is 18 hours. Compared to the non-AP courses, the maximum is 35 and the minimum is 0. So you can see the variability, at least according to the range. There's other measures of spread that we'll look at in this lesson. But as when it comes to the range, the students who aren't in AP classes have about double the range. So just as a statement, we'd say something like students who don't have AP courses have a much larger range, 35, than students with AP courses, which was 18. Now, why might that be? Well, you know, if students are in AP courses, they might not have time, but there could be other factors, right? Maybe students who are in AP courses are also more likely to be in sports. So maybe it's not that they're taking AP courses, but maybe it's because they're taking sports, and that's why they don't have a lot of time for work. And then students who aren't in AP courses, you know, it would make sense. Maybe they have more time to be able to take more hours at their jobs. So those are, that's comparing the center and the spread. On the next page, I've given you the same exact stem plot, so you don't have to turn back and forth. By the way, I didn't mention before, but the key on the stem plot kind of helps you out how to read 3/5, that would be 35. Number of, and then, you know, we have what we're actually measuring here. But anyway, calculate the median and the mean for each group. I believe we already did the mean and the median, but again, to find the position of the median, you do n plus 1 over 2, and that gives you the position for the median. So for the AP course, there are 9 values for the AP course. So we'd say n equals 9 on this side. And then on this side, it was 17, I think, n equals 17. So the median is going to be 17 plus 1 over 2. So it's at the 9th position, the 9th number when they're in order. Compared to on this side, we'd have 9 plus 1 over 2, which is going to be the 5th, excuse me, the 5th position. So 1, 2, 3, 4, 5, that's the median. Then the 9th position, 7, 8, 9. So the median for AP course, excuse me, the median is 9. And then the non-AP students, the median is 12. To find the mean is the same as the average. So to find the average for the AP course, students in APs, you would add up all the numbers. So 0 plus 0 plus 0 plus 5 plus 9 plus 10 plus 10 plus 15 plus 18. And you divide by how many you have, which there are 9 of them. So that looks like we would have 7.4 is what I got for that. Is the mean. And then for the no AP course, you can see why it's going to take a little while to calculate. We have a bunch of zeros, so that's not going to do anything. So a bunch of zeros. I'm not going to write them all. Then we have a 12, a 12, a 15, a 15, a 20, a 25, a 28, a 30, a 30, and a 35. And we divide that by 17, and that would be the mean. And I think we get something like 13.1, approximately 13.1 hours for the mean. So that's calculating the median and the mean. Those are called measures of center. Measures of center. They're called center because the mean gives you an estimate of where the center is for a data set, and the median is called a center because it's really truly the center. Its position is at the center of the distribution. I'd like to transition now to talk about that variability. Earlier, we talked about spread and variability of this data set. So I'd like to calculate something called standard deviation. And we're going to calculate that for the AP class. So first, let's just write down the has an AP course, all these numbers. So we had a 0, a 0, a 0, a 5, a 9, a 10, a 10, a 15, and an 18. So if we'd like to calculate the average distance from the mean, we'd like to know what the mean is, and I told you the mean right here is 7.4. So what we're going to do is we're going to take the number, the hours worked, and we're going to minus the mean from that. So we're going to do 0 minus 7.4. 0 minus 7.4. So that would be negative 7.4. This would be negative 7.4. Another 0 minus 7.4, negative 7.4. So what these numbers represent is this observation is 7.4 away from the mean. How far is 5 away from the mean? Well, 5 is negative 2.4 away from the mean, meaning it's below the mean. Negative is below the mean. 9 minus 7.4, that would be positive 1.6. That would mean it's 1.6 above the mean if it's positive. And then we have 10 minus 7.4, 10 minus 7.4, 15 minus 7.4. Cross all my sevens. Uh-oh, there's a lot of sevens. So that would be 2.6, 2.6, 7.6. Then lastly, 18 minus 7.4, which is 10.6. So that's the farthest away from the mean. And we'd like to find an average distance, right? That's what the question says, find the average distance away from the mean. So let's add up all of these numbers and see what we get. So if you take your calculator out, see if you could add those up. I'll take my calculator out. And what we get when we add those up, we get a sum. So maybe I'll write that over here. This is going to be our sum row. Our sum that you get, anybody get that? I got 0.4. Now I'm going to put this in quotes because that's not exactly the right answer. If you've been following along in your calculator, this mean should actually be like 7.44. So these are all rounded answers. So all these have been rounded. So you do get 0.4 if you add those. But if you find the sum using the unrounded number, using the 7.44, 7.444, you actually get a sum of 0. So when we try to find an average, that's going to be a really strange number. Also, even with the zero point 0.4 that we got originally, if we try to find an average, it's not going to make a lot of sense with our numbers. So the problem is when you're using an average, you're always going to have some numbers that are below average and some that are above average. So when you add a bunch of negative numbers and positive numbers, you're going to get 0. So there's two approaches that we could use to try to fix that issue. Like, we don't want any negative numbers. One approach is to do the absolute value of all the numbers, then add them. But the other approach that's actually more common, surprisingly, is we're going to do the hours minus the mean like we did before, and we're going to square them. So we're going to have that negative 7.4 that we had originally. We're going to square it. All these negative numbers, and then the positive ones we're going to square. There we go. And when we square all those, we get these numbers. There we go. And now when we add those, calculate, add a bunch of numbers, we get this number. 356.24. And then when we find an average, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll do that number divided by 9. And that will be our average deviation, which the special name for that is called the standard deviation, which rounding is 39.6. But actually, this isn't the standard deviation yet. We have one last step. 39, if you look at the numbers themselves, they don't look like the average distance from the mean is going to be 39. Because we'd squared all of these. So if we think of the units, all these units are square hours all the way down. So this number is squared hours. This number is squared hours. So this is squared hours. But the standard deviation is measured just in hours. So we should do the square root of 39.6. And then our answer is going to be 6.3 hours. And if you look at these numbers, if your average is 7.4, on average, these numbers are 6 hours away from 7.4. Some are closer than 6 hours away. Some are farther than 6 hours away. But look, these are really, that's kind of close to 6 hours away. These are kind of close to 6 hours away. Some of them are more. But then these are a lot closer. So on average, for the students in with AP classes, the standard deviation is standard deviation. Oops. The standard deviation is 6.3. There we go, standard deviation. So looking at the stem plot, which group, AP or non-AP, do you think would have the larger standard deviation? This one we just said was 6.3 standard deviation. This group, do you think it'll have a higher or lower standard deviation? I hope that you guessed higher. because there's a lot more variability, right? The range is much, much bigger, whereas this group is more compact. So this is gonna have a higher standard deviation. And if we were to calculate that standard deviation, we actually get 13 from the calculator. So it has about a double the standard deviation. I'd like to walk through that process one more time because it's a long process with these scores. These scores right here, we have fewer numbers this time. So let's find the variance and the standard deviation. Variance is a new term, but we kind of calculated it last time, we just didn't know it. So we have, let's just write the numbers like this first. Okay, so these are student scores on a test or something, and we're told the mean is 90. So first we do the distance each number is from 90. So that would be -6, -5, +2, +3, +6. And then once we have those, we square those to get rid of the negatives. So that would be 36, 25, 4, 9, 36. And we're trying to find an average distance from the mean, so we're going to add those. 36 plus 25 plus 4 plus 9 plus 36 is 110. Next, we're going to take that 110 and divide by how many scores we have. So we have 5 scores. So that would be 22. That 22 is the variance. The variance is what you get when you have before you square root. So this is like, if it's a score, say this would be square points. And this would be the variance is 22 square points. The standard deviation though would be the square root of the variance. So that would be square root of 22, which is 4.7-ish. And again, we take a square root to fix the units. We don't want square points, we just want points. So if you look at these scores, how much does one score vary from 90? Some are a little more than 5 away from 90, 4.7. Some are more. Some are pretty close to 90, but on average, they vary by 4.7 points away from the average. The last thing to talk about with standard deviation is I'd like to see if you can guess which of these 3 dot plots, which do you think has the highest standard deviation and which one do you think has the lowest standard deviation? So why don't you pause this video and see if you can make a decision about that. So the standard deviation is the distance from the center, from the mean. So let's mark where the mean is. Right here would be the mean. Right here would be the mean. And right here would be the mean. So the question is, for this question number 4, rank the following 3 dot plots as highest to lowest standard deviation. So the question is, which dot plot has the most points far away from the mean, from its mean? Well, these are pretty closely grouped together. These are pretty closely grouped together, but this one has a lot more spread away from the mean. So the second, the highest standard deviation would be the second dot plot. And the lowest standard deviation It's either the first or the third, right? Number 1, number 2, number 3. So this one has a couple points that, like these stack of 3, the stack of 3 that's far away from the center there, whereas this one has more points closer to the mean, a stack of 3, a stack of 3. So the lowest standard deviation, I would say, is number 3, has the lowest standard deviation. Thanks for watching this video. Please message me or your teacher if you have any questions about the video. And I hope you have a great day.